Hello. So, as I mentioned yesterday, that I'm going to share a problem on this vibration transmission, or you can say vibration isolation also. So, in this case, the problem is if you understand this problem properly and listen this video. So, any sort of problem where you will find out a vehicle with this attached to the spring or damper, or on the spring also moving over a rough road where the rough road details are given. So, you can definitely address these problems from wherever it may be. Okay, so in this case also we see that a vehicle of 500 kg, the question says that a two-wheel trailer has a spring stiffness of which deflects 10 centimeter under the weight of trailer 500 kg. So you need to find out that whatever information is given. So first information is that whenever I'm attaching a 500 kg on the spring, that gets a deflection of 10 centimeter. That gives you the idea of spring stiffness, because 500 kg is putting some weight on it and that getting deflection. So the K expression can be found out from the deflection value. Now moving forward, we see that dashboards are fitted between road wheels and body such that damping is 0.4. Damping is 0.4. 4 of the critical damping. So critical damping, we know that CC, and it is mentioned that the damping coefficient is C equal to 0.4 times of the CC. So C equal to 0.4 into CC. So therefore from here we get the zeta value, which is C by CC equal to 0.4. So indirectly this information is also given. Zeta is needed, as you have seen in yesterday's video. Zeta is needed in the expression of vibration transmission or isolation. The trailer is pulled over by a rough road which can be approximated a sine contour. Sine contour, you see, let me see, this road, this is one cycle I have drawn. Okay, this is approximated as a sine wave. Okay, now if I draw a dotted line about the mean point of this. Okay, so from this top peak to this bottom peak, we can see that this is the 5 centimeters. So the amplitude of each peak will be 5 by 2.5 centimeter. Now this is the sine wave, and as I have shown that time, this is a one cycle. Okay. Sorry, this is one cycle. Let me draw it properly. As I am doing it with mobile again, so it creates problem. Anyway, so this is one cycle. So in that way, whenever it is moving over the road, it is completing many cycle like this. So it is moving with certain velocity. So how many cycle it will cover, that will be decided. Now you see, after that there is no further information. Let's assume that the wheel don't leave the ground and tires are stiff. Tires are stiff, that is meaning that it is not providing any damping or spring stiffness. Okay, means that is not getting affected. So you need not to consider the material properties of that tire. Now it is not leaving the ground, that is also a indication. Sometimes this type of question is also asked, that when the velocity is very high na, that it will leave the ground. The vehicle will have a certain velocity upwards, then it will leave the ground. So that obviously we don't want, because we are bumping over a rough road and the vehicle will leave the ground. That means the travelers may fall. Okay, so that is also defined by the critical velocity. Okay, we might have covered that problem also. Anyway, whatever is convenient, that we are trying to understand here. Now here the last line is, find the amplitude of the vehicle movements of the body of the trailer if it is pulled at 60 km per hour. So it is mentioned that it is moving over this rough road by a velocity of 60 km per hour. This one, 60 km per hour. Okay, so let me see, and one more information is given from here. It is that from this peak to this peak means that one complete cycle, or you can say that can be from this point to this point also. That is also 15 meter. 15 meter. Okay, means each of this cycle is taking 15 meter. So, and we also know that the velocity is 60 km per hour. So I can find out that how many cycles it is covering in 1 second. How many cycles? Because these are nothing but each contour of the road is nothing but a cycle. So if it is moving by 60 kilometer per hour and each of these cycles, each of these peaks are having a span of 15 meter, so we can definitely find out the how many cycles it will cover in 1 second by dividing with the velocity. That's what we are going to do at the beginning. Okay, let us move forward. It is 60 kilometer per hour, that means the 16.67 or 66 meter per second. Therefore, with this speed, it covers how many bumps of the road, sine wave cycle. We can find it out by dividing the velocity with distance between two peaks. That's what I have done. Okay. तो ये 1 सेकंड पे मूव कर रहा है 16.66. सो एंड एक साइकिल है 15 मीटर का, तो कितना साइकिल, हाउ मेनी साइकिल इट इज़ कवरिंग, दैट वी कैन फाइंड आउट बाय this will give us the frequency in hertz or cycles per second value. Obviously, cycles per second we shall get, which is hertz f equal to 16.66 by 15. 15 कहाँ से आया? क्योंकि मैं जानता हूँ one cycle is covering a span of 15 meter. So this information from the graph will help you to find out the this important information, frequency. Frequency किसका है? When the vehicle is moving, इट इज़ क्रॉसिंग फ्यू बम्प्स, सो उसका फ्रीक्वेंसी है कि 1 सेकंड पे कितने साइकिल्स ये कवर कर रहा है. ओके, सो आई नो दैट फ्रीक्वेंसी इज हैविंग ए रिलेशन विद द सर्कुलर एंगुलर स्पीड ऑल्सो. सो you see 1 by tau, where tau is the time period, so tau equal to 1 by fn or 1 by tau equal to fn. So from there we shall get omega equal to 2 pi by tau, we know, and 1 by tau in place of 1 by tau, which is the time period, I can find out 2 pi fn. So if I substitute 2 pi into this 1.11 value, we shall get this 16.97 radian per second, which is the circular frequency, we can say, okay, or angular speed. Now angular speed of this value, this omega 2 pi fn, this is nothing but the exciting one. In the last day's expression of this vibration transmission, we have seen that there was one omega and there was one omega. This is that omega, that which is exciting the wheel or spring and dashboard system, and that response is trying to move on the trailer body itself, which is attached at the top of it. Okay, तो यहाँ से जो भी फोर्स आ रहा है और डिस्प्लेसमेंट यू से, दैट इज हैविंग ए फ्रीक्वेंसी ऑफ 6.97 radian per second. Okay, though always we confuse this one, circular frequency we should mention omega. Okay, because that frequency is nothing but cycles per second, which is having a unit of hertz. Now from the knowledge of static deflection. Okay, so as I mentioned at the very beginning, that how to find out the stiffness, k equal to w by delta, because due to addition of this 500 kg, the spring has got a deflection of 10 centimeter, which is 0.1 meter. So 500 into 9.81, and it is 49,050 Newton per meter. That is the stiffness we got. Now circular natural frequency I need to find out, because in the expression r was there. So omega we have got, so omega by omega n will be r. So omega n equal to root under k by m. K just we have found out, m is 500, so it is 9.9 radian per second. So I think it's clear, because all the informations were given, so there is no problem. Once we get the stiffness, we can definitely get the circular natural frequency, omega n. That was the earlier one, this one was circular frequency. Okay, now see, now in the last video, whatever expression was given, that is the vibration transmission or isolation, because in the same graph we have seen that one domain was transmission up to root 2 r equal to root 2, and beyond root 2 it is vibration isolation. Anyway, so here we can see that omega by omega n is less than that, less than root 2, because it is 6.97, it is 9.9. So it is definitely vibration transmission, and that's why whatever displacement the bump is road is having, and accordingly some amount of displacement will reach to the trailer body itself. Okay, और उससे ज़्यादा भी हो सकता है. That is the 2.5 is the displacement amplitude here, 2.5. So it can be more also. It can be 2.5 cylinder. It can be more in the trailer effect. The effect can be more also, because that domain is ट्रांसमिशन रेशियो इज़ ग्रेटर देन 1, तो ये तो ज़्यादा होगा, हमें मालूम है. So here is the expression that we are already familiar. Now the displacement and wheels are being transmitted to the trailer, hence the relation will be non-dimensional form. This is the non-dimensional form relation. So in this case, as the damper is present, that's why zeta terms are present. In many problems, you will see that only spring is attached. In such case, you will not, you will have to put the zeta value equal to 0. It will be then 1 by 1 minus r square. That is also a simplified form, and in many problems we directly can put that one. Okay, where x is the amplitude which the trailer will feel. X is the amplitude. Y is the base amplitude, 5 by 2, because from this peak to that top peak was 5, so it is 5 by 2, that is 2.5 centimeter. 2.5 centimeter, we are converting it into meter. R is the frequency ratio, as we have done, omega by omega n. Omega is the frequency of the moving wheel over the sine waves, 6.97 radian. Omega n is 9.9 radian. So R equal to 0.704. C is C by Cc. I have mentioned at the beginning also, 0.4 times of the Cc. हम दूसरी तरह से भी निकाल सकते थे C को, but we don't need that one. We are only bothered with the zeta, so it is 0.4. Okay. Now directly substituting this, twice zeta into r whole square, 1 minus r square whole square plus twice zeta whole square. So it is coming as 1.518. 1.518, which is by x by 0.25, x by y. So from there I am getting that x equal to 37.95 mm, or x equal to, we can say, 3.795 centimeter, okay, or 0.03795 meter. So I can see that though the base was excited or displaced by a amount of 2.5 centimeter, but due to the vibration behavior of the system which is attached to it, the transmission zone, it is obviously more, and more amount of displacement means 3.75 centimeter इस ट्रेलर पे ट्रांसमिट हो गया. So that's what I want to say, that in such type of problems, always just think on the, from the figure you will find many things. फर्स्ट काम जो है आपको उस वेलोसिटी जो दिया रहेगा, अगर ना भी दिया रहे देन इनडायरेक्टली समथिंग विल बी गिवन. सो फ्रॉम देयर यू हैव टू फाइंड आउट द फ्रीक्वेंसी कि ये जो ट्रेलर है कितने साइकिल कवर कर रहा है एक सेकंड पे. सो फ्रॉम वेलोसिटी और फ्रॉम एनी अदर, बिकॉज फॉर दैट यू नीड द पीक डिस्टेंस बिटवीन द टू पीक्स, द डिस्टेंस बिटवीन टू पीक्स, और चाहिए आपको वेलोसिटी. ओके, कभी कभी क्या रहता है कि सब कुछ दिया रहता है, वेलोसिटी नहीं दिया रहता है. Okay, that also appears. Then from other information you can find it out. And apart from that, because this expression needs this following thing, x by y, तो आपको x y फिगर से मिल सकता है. जीटा का वैल्यू किसी तरह अहम सी सी निकाल के भी निकाल सकते हो, और समटाइम्स सी एंड सी सी वैल्यूज आर गिवन, यू नीड टू फाइंड आउट फ्रॉम देयर. आर आपको निकालना है, बिकॉज फ्रॉम देयर वंस यू फाइंड आउट द हर्ट्ज, दिस फ्रीक्वेंसी मीन्स साइकिल्स पर सेकेंड, फ्रॉम देयर यूजिंग दिस रिलेशन omega equal to 2 pi fn, you will find out the circular frequency, और k by m से आपको natural frequency मिल जाएगा. From there you will find out the r, and gradually you will solve. So these problems you may find in different shapes, but the basic logic is same. एक्सप्रेशन को आपको सिर्फ दिमाग में याद रखना है, और उसके हिसाब से इससे सारे इन्फॉर्मेशन निकालना है. ओके, दैट इज़ द ओनली थिंग. ये कितने स्पीड पे, और एक चीज़ क्या है कि ये एक एक साइकिल को, रोड का एक एक साइन वेव जो है, एक साइकिल है रोड का, एक एक साइकिल को कितने टाइम लेके कवर कर रहा है. जहाँ से साइकिल पर सेकंड आपको हर्ट्ज इस फ्रीक्वेंसी मिलेगा, उस फ्रीक्वेंसी से आपको ये रिलेशन जो है सर्कुलर फ्रीक्वेंसी मिलेगा. ओके, सो इवन इफ एनी इंफॉर्मेशन इज मिसिंग, you must be sure that there is another information which is given which can be used to obtain that missing information. तो इसी तरह का ये प्रॉब्लम होता है. सो आई होप यू गॉट ए क्लियर आइडिया अबाउट दिस टाइप ऑफ प्रॉब्लम्स. इफ एनी डाउट अराइजेस, और इफ यू कैन फाइंड आउट एनी सॉर्ट ऑफ प्रॉब्लम which is having a defined variety, you can just send me the picture of it. I shall solve it and send it to you. Okay, so that's all. If you have any doubt, you can definitely write it down. Thank you.